Algebra 1, Section 10.3, Solving Quadratic Equations. We'll start with an example that I just made up, y equals x squared minus 4x plus 3. This is an example of a function. The way I have this designed right here is so that you would make a link between what you have highlighted in green. So notice down here I have x squared minus 4x plus 3 equals 0. Take a minute and notice what's similar and what's different about the two things that are highlighted in green. What you should have noticed that are different is that this one is y equals, where this one is equals 0. But what's the same is the quadratic itself, x squared minus 4x plus 3. Here you have x squared minus 4x plus 3. This is something that can be graphed. This is something that can be solved. This is something that has two variables. This is something that has one variable. Obviously, an equation doesn't have to be equals 0. They are often that, but not always. But the point is that there isn't a second variable here. If there's a second variable, then it's something that can be graphed, and we can find an infinite solution set to, rather than something that we can get a finite set of solutions. In this case, it's going to be 2. Oftentimes with quadratics, it's 2. Okay, so I went ahead and I did, with this function, I did go ahead and do a t-chart and then plotted those points. Now, quick link to a previous section. How did I figure out which x values to use? How did I figure out to put 2 in the middle? Well, I did negative b over 2a. Negative b over 2a would be negative 4 over 2 times 1, which would be 2. And then I picked 3 and 4, and I picked 1 and 0. This is just a convenient way to do things. Here are my outputs, and those were 5 convenient points to plot. Okay, 2, negative 1 is the vertex. That's this point here. And then where we're really going to focus today would be where those cross the x-axis. This point right here and this point right here, the points 1, 0, and 3, 0. Now, a term that you should already be familiar with is x-intercept, right? And that's what those are. There are 2 x-intercepts on this graph. They are at 1, 0, and 3, 0. And truthfully, for me, you can just say the numbers. 1 and 3 are the x-intercepts. You might have another teacher who wants the ordered pairs. In the future, if that's what they want, you do that. But to me, the x-intercept is a number. It's 1 and 3. Okay. Now, also 1 and 3 are zeros. Notice this highlighted word here. You'd see this highlighted in your book as well as you read that. 1 and 3 are the zeros, and the reason that they're called zeros is because it's where this graph, this parabola, the function, evaluates to y equals 0, right? Up here, y is equal to 3. Here's y is equal to 1.5 or so. Well, here's where y is equal to 0. And this point also is where y is equal to 0. Hence, they're called the zeros of the function. There are 2 of them in this case. Okay? Now, as it relates to the equation, x squared minus 4x plus 3, we'll use the word solutions, which should be a word you're familiar with, and then a new word, roots. Okay? And I wasn't the one who made the decision on using these 2 words, but these are just the words that the math nerds have been using for centuries. So you got to pick up the lingo. So they're called roots. What would be solutions to the equation are known as roots as well. Okay? And again, it's 1 and 3. Now, why is it 1 and 3? Well, again, you must understand, and this is the key point to the whole lesson. If I'm trying to solve this equation, what I can do is graph y equals the left side of this equation, like I did here, and find where it actually is equal to 0. Right here you have equals 0. Find where it's equal to 0. Those 2 x values are 1 and 3. Those are your solutions. Those are your roots. Those are the zeros to the graph. Let's take a look at an example. This one here says solve each equation by graphing the related function. And 2x squared equals 0, and then 2x squared plus 2 equals 0, and then 2x squared minus 2 equals 0. So notice how related those are. And I'm going to do another one for you here on the starboard. So let me just click to their answers here and kind of explain. Let's start with the one that's most like the one that we just looked at. 2x squared minus 2 equals 0. Okay. Now what they've gone ahead and done is graphed y equals the left side of this equation. Forget about y equals 0 for now. Forget about equals 0 for now. And then just graph y equals the left side of this equation. Y equals 2x squared minus 2. And they graphed it. And here's the graph, and it crosses the x-axis at these 2 points, 1 and negative 1. These are the 2 solutions to the equation. They are the 2 roots to the equation. They are the 2 x-intercepts slash zeros to the graph. feel free to use plus or minus 1, right? It's negative 1 and 1. You're welcome to use the plus or minus symbol, okay? Let's look at the opposite extreme. What if the graph lies entirely above, or for that matter, entirely below the x-axis? What I mean by entirely below would be if it did something like this, right? Never touches the x-axis. Well, that would be a no solution situation, right? There are no x-intercepts. There's no place where we can identify any roots to the equation or any zeros to the parabola. So we're just going to say no solution. Or the better thing to say actually would be no real solution. Okay, that becomes more relevant to you in Algebra 2. There are no real solutions. In fact, there are 2 non-real solutions to this. But if you said no solution, that's good enough for now. And by the way, the reason there's no real solution, or an additional reason why there aren't any solutions, is that you can't find a value for x that would make this true. Okay, if you don't believe me, try it. Try plugging in values for x, and that would make this equal to 0. Those numbers don't exist. Okay. And then finally, what else can happen? The third possibility is that it can just touch. Rather than crossing twice, a parabola will often pass through and then pass back through. That's the nature of a parabola, down, up, right, or up, down. Or just totally miss like this one did. The other thing that it can do is, of course, just come down and just touch it. And if it just touches it, well, then there's one solution. There was the potential for 2, but it only touched it in one place, and that would be x equals 0. The solution is just that one point where it touches, and it's x equals 0. Okay? Let's practice another example like that. And we're asking to solve by graphing. We're being asked to solve by graphing 2x squared minus 32 equals 0. And what I will first do is go y equals 2x squared minus 32. And then I'll make a quick t-chart and a quick negative b over 2 calculation. Did you notice on this one, and also in the last 3, on that last example where we did 3 of them, that the b value was 0? So you go to do the calculation, negative b over 2a. Negative b over 2a is like saying negative 0 over 2 times 2. Well, that's just 0. So my x value of my vertex is going to be 0. And as I plug 0 into this x value, 0 squared times 2 is 0 minus 32 would be negative 32. How about 1? 1 squared times 2 is 2, minus 32 would be negative 30. How about 2? 8 minus 32 is negative 24. Try 3. 3 squared is 9, times 2 is 18, minus 32 would be negative 14, and 4 would be 16 times 2 is 32, minus 32 equals 0. Okay, so that's the one we were actually looking for. If you do negative 1, negative 2, negative 3, negative 4, just going to go a little fast to save us some time. You'll get negative 30, negative 24, negative 14, and again, you'll get 0. Okay. Now, if you want to plug in 5 or whatever, you can do that too. But the important points that we were looking for, because we wanted a solution, would be where they actually evaluate to 0. Now, let me go ahead and just take a moment and change the scale. Let's go by 5s. 5, 10, 15, 20. Here's negative 20. So that we can see this whole graph. And negative 4, 0 will be here. 4, 0 will be here. We'll come back to those in a second because those are our solutions. Negative 3, negative 14. 3, negative 14. Negative 2, negative 24. Negative 1, negative 30. And then our vertex is at negative 32, like right about like this. Okay, so you can draw a fairly nice looking complete parabola like this. Don't get sloppy on the parabola just because it's the solutions we're after and not as much the graph. I mean, I still want to see your graph. So draw a nice looking parabola, and then what we want to do is identify the x-intercepts as the solutions, okay? So our answer would be x equals plus or minus 4, or you could list them separately, negative 4 and 4. Okay, do you understand? What did we just do there? We just found the solutions to this equation by graphing the left side, y equals 2x squared minus 32, and actually finding out where it's actually equal to 0. Where is it equal to 0? Well, we're on the graph where it actually is on the x-intercept. That's when the y value isn't any of these numbers, it's 0. So plus or minus 4. All right, a couple more things. The other method that is highlighted in this section is to solve using square roots. Okay, so we just did solving by graphing. The other way to do this would be to solve using square roots. And this doesn't involve a graph at all, but to rather just solve this as you would any other algebra equation. Okay, and what you'll often hear me say in class is ask yourself what's happening to the variable and then undo things in reverse order. Okay, so my variable is being squared, and then it's being multiplied by 3, and then being subtracted by 75. The way I said that was correct by orders of operation. Powers first, then multiplication, then subtraction. So x is being squared, multiplied by 3, and subtracted by 75. What I'll do first is add 75 to both sides of the equation, divide by 3, and then the last step, and this is critical, you're going to square root. Don't forget plus or minus. Aren't there two solutions to x squared equals 25? Yes, 5 squared equals 25, but also negative 5 in parentheses, as in you plugged a negative 5 in for x and the whole thing gets squared. That also is equal to 25. So when you do this, and I'll show the step, when you take the square root of both sides, you need to remember to include plus or minus. Okay? X equals plus or minus 5. This is not something that I can just make you to remember. You ought to just be in the frame of mind with quadratics that we're looking for two solutions. A lot of the time we do get two solutions. So, hey, where's the two solutions? Well, you got to remember to do plus or minus when you do the square root. Okay, one more example then. A museum is planning an exhibit that will contain a large globe. The surface area of the globe will be 315 feet squared. Find the radius of the sphere producing this surface area. And then they gave us an equation that you ought to be familiar with. Geometry graduates, right? Surface area is equal to 4 pi r squared. They gave us the surface area. Now we are going to need our calculator for this one to find the radius, and this is related because r squared, that does bring in the fact that it is quadratic. So what I'm going to do is I'm going to take 315 and I'm going to divide it by 4 pi. Careful, if you do this on your calculator, make sure you put 4 pi in parentheses. Or divide them one at a time. 315 divided by 4, enter, divided by pi, enter. And that's about 25.1. And I'm not going to take the square root of 25.1, but rather I'm going to take the square root of the number on my calculator because it's more accurate. And I get 5.0066858884. They did not tell me what to round to, so I'm going to go with nearest tenth. R is equal to about 5.0. Now again, technically, what I would have is plus or minus approximately 5.0 and on and on. But we are talking about a length here. A radius is a length, and it should be in feet. So we only want the positive number there. And of course, they didn't round to the nearest tenth. They rounded to the nearest whole number. But your book should tell you, on a problem like this, your book should tell you what to do. Okay, last thing real quick is just a reminder that you'll just need this in your homework today, that the area of a circle is pi r squared. I hope you remember that one. And then even simpler than that, the area of a square. Okay, so this was circle. Square is just the side length squared. Okay, now I know you know that already, but I always give that reminder before I give this homework assignment. So if you need those, there they are. Thanks for tuning in.